Hello everyone, this is Robin Gurjar, Assistant Professor, Department of Civil Engineering, SISTec-R. In the previous lecture, we have studied what are influence lines, how influence lines are drawn, and various related aspects related to rolling loads, such as importance of rolling load, etc. In this video, we will solve some numericals based on influence lines and rolling loads which are asked in previous year in your university exam. So let us revise some previous topics which we have studied. Definition of an influence line. An influence line represents the variation of the reaction, shear, movement or deflection at a specific point in a member as a system of loads move over the member. So this we have seen that influence line diagram provides the idea about the variation of different stress resultant such as shear force, bending moment or variation of support reactions at a specific section due to the movement of loads. This is the ILD for shear force at section. This. So we have seen that this ordinate is equals to L minus Z upon L. This length upon total length and in negative direction, in negative Z upon L. So this we have seen in the previous video that how this is drawn, and all the related aspects we have seen in the last video. Similarly for ILD for bending moment, we have seen that how ILD for bending moment is drawn. This value is given by L minus Z into Z upon L. Let me revise once again. This ILD of bending moment is giving us the idea about that how bending moment will change at point C if the load is moving from A to B. For example, if I will ask that give me the bending moment at C, give me the bending moment at C when the load is at A. So you will go here and you will see that the ordinate here is 0. So you will say that sir, the bending moment at C when the load is at A is 0. If I will ask give me the bending moment at point C when the load is at C. So you will calculate this ordinate. We have calculated in previous lecture. This is L minus Z into Z upon L. Okay. Similarly, when we will come to B, so you will, if I will ask that what is the moment at C when the load is at B, so you will say it is 0. Okay. So now let's start with some numericals. Okay, this is numerical 1. Okay, so the question is two wheel loads of 16 kilonewton and 18 kilonewton at a distance apart of 2 meter cross a beam of 10 meter span. So the total span is 10 meter. Draw the influence line for bending moment and shear force for a point 4 meter from the left abutment and find the maximum bending moment and shear force at that point. So in this question it is asked that find the maximum shear force and bending moment at a point which is 4 meter from left, that is this point. The total span is 10 meter and the maximum shear force and bending moment is asked at this point C, which is 4 meter. Okay, so see, first of all the first step in such type of numericals is you have to draw diagram, and before solving any numerical first understand the question very carefully, what the questioner is asking, what he is asking, and after that draw the diagram. Okay, so for maximum shear force at 4 meter, this is 4 meter. First of all the first step in ILD is draw the influence line for whichever stress resultant he is asking. Here he is asking for shear force, so draw the stress resultant for shear force. We have seen the positive is given by L minus Z upon L. So here this distance will be 6 meter. 6 upon total length is 10. So this is 6 upon 10, that is 0.6. This ordinate is given by 0.6. Okay, and here it will be given by Z upon L, that is this distance is 4. So 4 upon 10 is 0.4. 4. Okay, so this we have drawn the what ILD for shear force. Okay, if now we will move further. So maximum shear force will occur when 18 kilonewton will be at C. There 16 kilonewton, therefore 16 kilonewton will be at 4 meter from B. Okay, what does this mean? This mean, okay, what he's trying to say, he want to say that when 18 is multiplied by 0.6, this is a bigger ordinate and this ordinate is smaller. So if we will multiply 18, which is a greater number, with a greater ordinate, hence only we will get the maximum value. So we will multiply 18 with 0.6. This is trial and error. Okay. Okay, now we will move forward. Ordinate under 18 kilonewton is 0.6. Okay, this is 0.6. We have calculated by 6 by 10. Ordinate under 16 kilonewton is, let this is be RS. We have assumed this distance as RS. So by similar triangle, we can write as RS upon 4. This side upon this side will be equals to, this is 0.6 upon 6. So we will get RS equals to 0.4. This we have solved. Okay, hence total shear force will be equals to the force into ordinate. So here the 18 kilonewton will be at 0.6. So 18 into 0.6 plus 16 into 0.4. So here we will come this 18 into 0.6 plus 16 into 0.4, that is 17.2 kilonewton. Okay, similarly we will draw for bending moment diagram. Okay, for maximum bending moment diagram, the ILD is given by this type of diagram, which we have also seen in previous lecture. This ordinate is given by this distance, that is Z into L minus Z upon L. So this distance is 4 and this is 6. No, 6 into 4, 24 upon 10, that is 2.4. This I have written 6 into 4 upon 10. Okay, for maximum bending moment will occur when 18 kilonewton is at C. When 18 kilonewton will be at C, so the maximum bending moment will occur. Hence 16 kilonewton will be at 4 meter from B. Okay, first of all we will calculate this ordinate. Similarly, as we have calculated in for shear force, we will calculate here for bending moment. So RS upon 4 will be equals to PQ upon 6. Therefore RS will be equals to 1.6. Here maximum moment will be equals to load, that is 18 into ordinate 2.4, and at under 16 kilonewton load the ordinate will be RS. So 18 into 2.4 plus 16 into 1.6 equals to 68.8 kilonewton meter. This we have solved. Okay, many students ask the doubt that how to solve this similar triangle. So we have another trick also for this. Let us see. Okay, suppose these are two triangle BDC, okay, and triangle AEC. So if you are confusing that how corresponding sides are divided in the same ratio in similar triangle, so we have another trick also for these type of questions, that just calculate the tan theta for both the triangles. For this triangle BDC, the tan theta will be equals to DB upon BC. Similarly, for this triangle AEC, tan theta will be equals to AE upon AC. And we are observing that theta is same for both the triangles. Theta is same, hence tan theta will be same. So therefore AE upon AC will be equals to DB upon BC. So you can also calculate the ordinates by this trick. Okay, so now we will move to our next numerical. Okay, so this is also the question of our question bank, question number 6 of our question bank. So in the given question, we have been asked to find maximum bending moment and shear force at 4 meter from left support and 5 meter from right support. So in this question, in total there are 2 points given at which you have to calculate these absolute maximum bending moment. Okay, so first we will solve for at 4 meter from left support. Okay, so at 4 meter from left support. So first of all we will draw the ILD for shear force. This is the ILD for shear force. So this we will calculate. This will be given by 4 upon total length 18, that is 0.22. Another ordinate will be equals to 14 upon 18, that is 0.78. Okay, so this we have drawn what? The ILD for shear force. And the total length of UDL was given in question is 5 meter. So at 5 meter we will calculate this ordinate by that rule, similar triangle rule. So that will be equals to suppose this ordinate is x. Okay, so x upon 9, 14 minus 5 is 9, x upon 9 will be equals to 0.78 upon 14. Okay, so here you can calculate x equals to 0.5. Hence now this shear force diagram, positive shear force diagram is divided, is our trapezium. Here we are watching that this is trapezium, and the area of trapezium is given by half sum of parallel sides into height. So the parallel sides here are 0.78 and this what we have calculated as 5. So half 0.78 plus 5 into 5 height, half sum of parallel sides into height into intensity of UDL. So here we will get 64 kilo Newton. For negative bending moment, all this force, this will come here. Okay, this UDL will be placed here. So maximum negative bending moment will be equals to half into 4 base into height 0.22 into intensity of UDL, that is 8.88, and here the sign is negative, so we will put a negative sign. This we have calculated shear force. Okay, maximum bending moment. For maximum bending moment at section for UDL, the load position should be such that the section divides the load in the same ratio as it divides the span. Okay, so what does this mean? इसमें सीधे सीधे ये कह रहा है कि UDL के केस में जब उसकी लेंथ टोटल स्पान से कम होगी, मतलब इसमें टोटल स्पान इन दिस क्वेश्चन टोटल स्पान इज 18 मीटर, टोटल स्पान 18 मीटर है और यूडीएल की लेंथ है 5 मीटर। इसका मतलब क्या कि 5 मीटर 18 मीटर से कम है, मतलब कि यूडीएल का स्पान यूडीएल की लेंथ टोटल स्पान से कम है। इस केस में मैक्सिमम बेंडिंग मोमेंट किसी भी पॉइंट पे कब मिलेगा आपको? जब स्पान उसी रेशियो में डिवाइड हो, यूडीएल उसी रेशियो में डिवाइड हो जिस रेशियो में स्पान डिवाइड हो रहा है। अपने केस में स्पान किस रेशियो में डिवाइड हो रहा है? 4/14। इसी रेशियो में जब यूडीएल डिवाइड होगा देन ओनली वी विल गेट मैक्सिमम बेंडिंग मोमेंट एट दिस पॉइंट। ओके, सो मैंने इस पॉइंट से सेट, जिस पॉइंट पे मुझे मैक्सिमम बेंडिंग मोमेंट चाहिए उस पॉइंट से मैंने मान लिया कि यूडीएल के जो टेल की पोजीशन है, ये जो पीछे वाला जो पार्ट है इसको बोलेंगे टेल। टेल मतलब पूंछ, तो जो पीछे वाला पार्ट है यूडीएल का उसको मैं आई विल से टेल। ओके, सो मैंने मान लिया सी पॉइंट से इस टेल का डिस्टेंस है x। okay, so total length was 5, so the remaining length will be 5 minus x. Okay, so it will divide in the same ratio, so x upon 4, this is x upon 4 will be equals to 5 minus x upon 14. So x upon 4 equals to 5 minus x upon 14. This implies x equals to 1.11 meter. Okay, now we have to calculate maximum bending moment. So we need these ordinates, this y and this x. So this we will calculate by similar triangle. So y upon this distance, this will be equals to 4 minus 1.11, so that will be equals to 2.89, that will be equals to 3.11 upon 4, so we will get y equals to 2.2. 25. In the next, this triangle, in this triangle, x upon 10.11 should be equals to 3.11 upon 14. So that will be equals to 2.25. Okay. Okay, so we have calculated these ordinates. So this total figure of UDL, this from this y to this x, these both comprises of two trapeziums, this trapezium and one in the second this trapezium. So we will add the area of both this trapezium, that will be equals to half into 2.25 plus 3.11 into 1.11 plus half 3.11 plus 2.25 into 3.89. This will come as 13.39, and the maximum bending moment will be given by 13.39 into 20, that is the intensity of load. 20 is the intensity of load, so we will get 267.79 kilonewton meter. Okay, so we have completed the first part of the question. Now second part, for 5 meter form, right? This I am giving for you. You practice this form for 5 meter form, right? Okay, for absolute maximum bending moment. तो एब्सोल्यूट बेंडिंग मोमेंट वो बेंडिंग मोमेंट होता है जो कि एब्सोल्यूट वैल्यू आपको देगा मैक्सिमम की। इसका मतलब क्या कि अभी पिछले दो पार्ट में उन्होंने बोला था कि आप एक स्पेसिफिक सेक्शन पे बताइए इस पॉइंट पे क्या होगा, लेकिन एब्सोल्यूट मैक्सिमम बेंडिंग मोमेंट में वो ये बोल रहे हैं कि आप हमें टोटल होल स्पान में बताइए कि मैक्सिमम वैल्यू कब अकर होगी जब वो लोड यहाँ से ए से बी की तरफ मूव होगा। सो यूडीएल के केस में जब यूडीएल स्पान से लेस लेंथ का होता है तो एब्सोल्यूट मैक्सिमम बेंडिंग मोमेंट की वैल्यू अकर होती है सेंटर पे, वो भी तब जब वैल्यू सेंटर पे अगर हो रही है, इसका मतलब क्या है, यूडीएल भी सेम रेशियो में डिवाइड होना चाहिए, दैट इज हाफ. So total length of UDL was 5. So this total length will be equals to 2.5 and this will be equals to 2.5. So you can calculate in the similar way as we have calculated in the previous question. So this will come as 387.50 kilonewton meter. Okay, now we are having next question. This. In this question, simply the shear force diagram and bending moment diagram was asked for the given figure. Okay, so it is given that 4 wheel loads of 6, 4, 8 and 5 kilonewton crosses a girder of 20 meter span from left to right, followed by UDL of 4 kilonewton per meter and 4 meter long, with the 6 kilonewton load leading. The spacing between the loads in the same order are 3 meter, 2 meter. The head of the UDL is at 2 meter from the last 5 kilonewton load. Using influence lines, calculate the shear force and bending moment at a section 8 meter from left support when the 4 kilonewton load is at center of the span. Okay, so first of all we have made this diagram. Okay, one thing I will like to share you, that when you are making the diagram, you are drawing the diagram, so keep in mind that this order should not be reversed. Okay, first the load is given is 6 kilonewton, so draw 6 kilonewton, then 4 kilonewton, then draw 4 kilonewton. Okay, so you have to remember the order very carefully. Now it is given that the 4 kilonewton load is placed at center. Okay, so this is at center, total span is 20, so this 7 plus 3 is 10, and here also we are having 10. First of all we have drawn this diagram. Okay, now we have to calculate shear force diagram and bending moment diagram. First we have drawn ILD for bending moment diagram. This is given by Z into L minus Z upon L. So this is 8. 4 plus 2, 6 plus 2, 8. 8 into 12 upon 20. Okay. Similarly, we will draw for shear force diagram. This we will get as 0.6 and this we will get 0.4. How to draw this diagram we have seen in various questions previously. Okay, now we will calculate ordinates for bending moment. We will take different triangles, both the triangles. So we will, in that diagram we will see that AC upon CC dash will be equals to AE upon EE dash, that will be equals to 8 upon 4.8 will be equals to 6 upon EE dash. This will give you EE dash equals to 3.6. Similarly, we will calculate the other ordinates. So we will get DD dash equals to 2.4, F dash equals to 4, and G dash equals to 2.8. Okay. Okay, for bending moment at C, we will multiply all the respective loads. So we will get half. This is for UDL. Then we will multiply 5 into ordinate, that is 3.6, 8 into 4.8 plus 4 into 4 plus 6 into 2.8. We will get 108.40 kilo Newton. Similarly, we will solve for shear force. We will get in negative shear force. We are also having negative. Okay, so these are the ordinates which we will calculate for negative, and these are the ordinates for positive. This we have calculated using similar triangle. This will be equals to 0.5, this will be equals to 0.35. Okay, so calculate for respective load. We will get minus 2.2 kilonewton, and this maximum positive shear force we will get 5.80 kilo Newton. Okay, thanks for watching the video. If you have any doubt, then you can contact me. You can mail me your doubt on this mail ID, or you can WhatsApp me on this number. Thank you.